So in this section, we're going to look at several different things. We're going to look at simplifying radicals with calculators. We're going to look at them without, and we're going to look at a couple other topics. But we're going to start with the calculator. And so some of the problems that you're going to see today are going to look like this. So you'll definitely want to have your calculator out as we're working through these problems together.
Which one do you...
Yeah, at this point we should shift away from the little TI-30. We should be using our graphing calculator exclusively. And for those of you who are still learning how to use that calculator, that's part of what we're going to be doing in this section. Okay. So, a couple things that we need to think about. When you see directions like this, it's telling you to use the calculator. Okay. And one of the reasons it's telling us that is that 43 does not have factors that have something to the fifth power, because that's what we'd want to have happen, so that it would cancel out with this fifth root. This is pronounced fifth root. This is the fourth root. Okay, so here's some other terminology. Okay, the number underneath the radical is called the radicand, and the little number that sort of sits in the V there, where normally there's not a number, what we've been used to is when there's not a number there, it's understood that it's a square root. Okay, but we can use different numbers in there to do cube roots, fourth roots, fifth roots, that kind of thing. And that's how we pronounce that. Okay, I'll let you kind of write those terms down first, and then I'll move on to the next part. We pronounce that as the fifth root on the left when it's when you have the little 5 in the radical symbol, and when you have the little 4, it's the fourth root. When you have a 3 in there, we call it the cube root. We don't call it the third root. When there's nothing there, of course, we know it's the square root. And then, of course, when we go on from there, 6th root, 7th root, 8th root, etc. Okay. So here's the keystrokes on your calculator that you're going to use. Okay. So, for example, for this first one, you're going to type in 5. You don't have to put the comma. I just put that so you understand that those are 3 different keystrokes. Okay. There's a button on your calculator that looks like a radical with a little X in the index.
Where?
I believe it is
I don't see that button.
math menu. So go ahead and click the math button, which is underneath the little green button, and it's the 5th one down. Okay. So hit the math button, and then scroll on down to where you see the little radical with the X for the index. And then when you type in -43, make sure you use the negative symbol. Don't use the minus symbol, the subtraction symbol. So use the one that's in parentheses next to the decimal underneath the 3.
2.121747.
If you recall, the directions said round to 3 places. Okay. And I know it's not on that screen now, but on the first screen it said round to 3 places.
So it's -2.12.
Yeah, so that one is going to be -2.122. Go ahead and verify that the fourth root of 71 is 2.903. It's going to be part of what you do, a very small part of what you do for your homework today, but I wanted to show you how to use your calculator for that. Let's understand what this means, okay? When I take this number, now granted, obviously there's a lot more decimals after this that we did not include. If I took this to the 5th power, I would get -43. If I took this with all the decimal points to the 4th power, that would give me 71. Okay, so again, understand that powers and radicals are inverse operations. We've talked about that exclusively with square roots and squares. Okay, but it works for all powers and indices is the plural of indices, okay? Alright, let's get into some stuff that's a little tougher. Okay, so a couple problems that you're going to see. Of course, we're going to have variables. Okay, when you see the plus or minus already in front of the radical, that means you're going to have a plus or minus as part of your answer. Okay, in this case, we'll have a minus as part of our answer. but there's a couple things that we need to discuss so that we're all on the same page. The goal here is to think about how could I rewrite this as something squared so that the radical and that squared, the power of 2, cancel each other out. And then I can basically just get rid of the radical. Okay? What I need to be thinking is what squared equals 16y to the 4th. Don't say it out loud. Don't say it out loud. If you think you know what number squared gives you 16y to the 4th, go ahead and write that down. So think about it in two different ways, okay? Think about the number part. Okay, so what number squared gives me 16? 4, okay? What number squared on the variable part? So what variable squared will give me y to the 4th? Y squared, okay? So in reality, what I'm thinking here is that 4y squared gives me the 16y to the 4th. And the reason that we do that, and that's why I highlighted the red and green there, is those two are inverse operations and they just cancel out. Okay? So for this, we can just cancel out the square root and the square, and so I end up, my final answer is plus or minus 4y squared. Okay? The plus or minus is only there because the problem started off with that. When we take the square root of a number, we don't typically get a plus or minus. We just take a positive for a square root. It's only because it was there to begin with. And one of the reasons that it's there, and we've gotten used to that, is when we solve equations where the variable is squared and we have to square root both sides, we end up getting that plus or minus. Okay. Now, for the next one, I've highlighted the x squared minus 6 for a reason. Okay? I don't want you to view that as separate things. I want you to view it as one term to the 8th power. If you do that, it'll become easier to think about converting it to something squared like we did for the first one. Because again, what I want to do is I need to think what number squared is going to go inside there. Okay? And if you think of this as just one term, I mean, for that matter, you could think of this, if you wanted to, I'm just going to write this over here. You could think of this as like y to the 8th. Okay? Where in this case, y is the x squared minus 6. Okay? If you want to think about it that way, you can. Again, my point is that I want you to think about this binomial as just one thing. I get that it consists of a couple different terms, but think of it as one group. So, what to the 2nd power is going to give me something to the 8th power? Meaning, what has to go in here?
2.
What? So 2 to the 2nd power gives me 8, something to the 8th power? So let's think about what we did over here, okay? When we were trying to figure out how to write this as something to the 2nd power, we had a power to a power.
x4 minus x.
So to what power am I going to have something in here in order to turn it into an 8? 4. The power is going to have to be 4. So in reality, it's going to be something to the 4th power to the 2nd power. Because we know that power to a power you multiply, and if we're undoing that, we're really just going to divide. Okay? 8 divided by 2 gives me 4. Now, this part here was that what I had written over here. Well, what is the thing that has to be raised to the 4th power? X squared
And minus 6.
minus 6. The whole thing, the whole group has to be raised to the 4th power. Okay? The whole thing has to be raised to the 4th power. Because again, think of it as just one group. Okay? So now we're back to the situation where I have something squared and a square root, so those cancel out. Okay, so I have this square root, and I have the squared, so they cancel out, which means I'm left with just the x squared minus 6 to the 4th. Okay. And that's it. The trick for you when we start looking at variable and variable groups is thinking of it as one group, not separate terms. Now, I went ahead and I wrote the little 2's in here, and the reason that I did, and I alluded to it already, is if I notice that 4 divided by 2 gives me 2 when it comes to the powers. 8 divided by 2 gives me 4. You can divide a power in the radicand by the index, and that will give you the power for your answer. Okay? And we're going to talk more and more about this as we move through chapter 6. But that's a skill that I want you to, a technique that I want you to start thinking about as we work through these. If you're struggling to figure out, for example, for those of you who are struggling to come up with this 4, if you just went 8 divided by 2, that's where it would come from. 4 divided by 2, that's where this would come from.
So I just
Okay.
divide it all by 2.
No. Powers by 2.
Yeah.
Powers, yes. Now, that's when it's a square root. As we've seen on the previous page, we had indices that were not 2. They were 4, they were 5, they're going to be 3, they're going to be different numbers. But that division idea will still work, okay?
So if it's divided by 4, take whatever the power is inside.
Alright, let's look at a couple more. And we're going to use that division idea as well. Okay, obviously when we get to the 5th root, you don't know your perfect fifths, right? We're still learning our perfect cubes.
Wait, so what was the answer to the last thing?
So again, we can rewrite this, if we want, as something all to the 5th power, and then it'll cancel with the radical. Alright? The thing that's nice is now that we've talked about the division, the variable part should be pretty easy. Okay? But we need to figure out what number to the 5th power might go into this. So I want you to play around with that and see if you can figure out what number to the 5th power gives me 243. So grab your calculator and play around with that a little bit and see if you can figure out what it is. Don't shout it out. If you get it, write it down. And for that matter, you could actually also just type in the 5th root of 243 and see if it comes out even. The trick is if it doesn't come out even, that's where you're going to have a dilemma. Question.
Got it.
Does it come out even, the 5th root of 243?
Yes.
What is it?
3.
Okay. So, and then with that division piece, I could rewrite this as a to the 4th, b to the 5th. Now, you're going to get to the point, so I want you to think of them all separate. That's why I drew those lines in there. Okay. In reality, this is 3, a to the 4th, b to the 5th. Okay, you're going to get to a point where we can jump from here to the answer. Okay, but for now we're going to write it all out. 3a to the 4th, b to the 5th, all to the 5th. The 5th power and the 5th root are going to cancel. I'm just left with 3a to the 4th, b to the 5th. So like I said, if you employ that division technique, I can go right from a to the 20th. The 5th root of a to the 20th is a to the 4th. The 5th root of b to the 25th is b to the 5th, and since this one actually worked out, it's not always going to work out. The 5th root of 243 is 3. Okay?
What if it doesn't work out?
If it doesn't work out, then you're going to have to break the numbers down and see if you can find a perfect fifth that goes into 243. And with the variables, when they don't go in evenly, if let's say this would have been 21, okay? So if it would have been 21 here, you would have still got an a to the 4th on the outside, but you'd have a remainder, right? 21 divided by 5 is 4, remainder 1, which means there would still be a radical with 1 a inside. And we've talked about that a little bit too, okay? Now, what's my dilemma over here?
A negative.
Okay, I have a negative and it's a square root. We can't take a square root of negative, which means we're going to have what for our answers? I's. There's going to be imaginary numbers. Now, that being said, if this index was odd, 3, 5, 7, 9, etc., we can have a negative in there. It's when this index is even that we have a problem, okay? And you're going to need to start paying attention to that too, because you can't multiply a number by itself an even number of times and ever get a negative. Now, I can still deal with this x to the 4th, the square root of that, and I can still deal with this y to the 8th, the square root of that. But what's the square root of negative 16? 4i. Now, here's where it seems kind of counterintuitive. Why would there be two answers? And it's because there's imaginary numbers. Okay? They want us, when we take the square root of a negative, to have both 4i and negative 4i. Okay? Notice the variable parts are the same. Okay? I still have 4 divided by 2 and 8 divided by 2, so I get x squared and y to the 4th. But because of that negative 16, and we've only, until today, we would have all said this was 4i, and that's it. But now we also need to include negative 4i. Okay, this is not going to come up too often, but every once in a while it will, and I want to expose you. This is the only instance where you take the square root of something and get a plus and minus when they're imaginary. Okay, and if you want to write plus or minus, you can. It's the only instance where that happens. So if you would have written it like this, that would be fine. Okay? We have some exceptions. We have a situation where we have exceptions. And I want to talk about when that happens and what you need to look for. Okay? Because until now, you would have never even probably contemplated this. So here's the first part. Okay, when you find an even root of an even power, and the result is an odd power. We're talking just about roots, the index, and powers. That's all we're talking about. You have to use the absolute value. And when we're talking about this, we're talking about it with respect to variables. Okay? So all of these even powers and odd powers things are on variables. Okay? Write this down. Write this down. So I've highlighted those words even, even, odd. That's going to be your key, even, even, odd. If you can remember even, even, odd, then you're going to know it's going to need absolute values. Or you're going to know it might need absolute values, and I'll talk about that. If it's an odd root, if the index is odd, we don't need to worry about absolute values. Okay? The only time you have to worry about absolute values is if the index is even, and then you only have to worry about it if the power on the inside is even and the answer is odd. Okay? And when we look at an example, I will show you what I mean. I wrote the word variables and then I didn't even pay attention to my own notes. This is for variables. And I'll explain exactly why we have to watch for that. And the truth is, the reason we have to watch for that is we don't want to be in a situation where my radicand could potentially give me imaginary numbers. This is a way to avoid imaginary numbers. Okay. So here's a couple examples. All right. We'll start off super easy. So right away, anytime you have a square root, 4th root, 6th root, 8th root, an even index, you need to be on alert. Okay? Because it's possible that I might need to use the absolute value. All right? Inside I have an even power, so I have even, even so far. If my result gives me an odd power, I'm going to have to use the absolute value. You'd look at this and think right away for the first one, well, what is that? The 4th root of y to the 4th. What should it be? Y. Okay, they just cancel each other out. You would think y. Here's what our dilemma is. We don't know what y actually stands for. And I can't take a square root or a 4th root or 6th root or 8th root and produce a negative number. So in this case, what's happened is I do have even odd situation. Okay? Even index, even power inside, and then the outside power is odd. So because of that, even odd, my answer is actually the absolute value of y. What this does is it ensures that even if y ends up being negative, the absolute value will force the result to be positive. Okay? So only when it meets these conditions, even odd, even index, even power on the inside, odd power when we simplify, do I need the absolute values. And you only need it for the parts that have the odd power. Like for example, on this second problem, I've got even index, I got an even power on the inside. Alright, 18 divided by 6 is 3. So I'm going to have even odd, which means I'm going to have some absolute values in there somewhere. The 64 is not affected by that. Can you take the 6th root of 64?
Yes.
What is it?
2.
2. So I get a 2. Oh, sorry. That's what we were talking about before. 6th root of 64 is 2. Okay. Now on this other part, I do get x squared minus 3. Again, think of it as one thing to the third power. But because it's even odd, I have to put absolute value just around the part that's to the odd power. I don't need to put it around the 2. 2's already positive. We're good. Doesn't need to be around the 2. It just needs to be around the part that is to the odd power, to ensure that that thing is positive.